Welcome to the Talking with the School of Transportation podcast, presented by Centennial College. With your hosts, Ian Campbell and Harnett Gill, let's get into it now.
And we're back. I'm here, as always, with Harnett Gill.
Thanks, Ian. Hello, everybody. We're joined by Garrett and Nalepka, who is returning. I think this is maybe his third time. Is that right?
Third time? Possibly.
Third time. And also Justin Gullison.
The return.
Who's like the return. I think this is this your
It's only my second.
Yeah.
second time only? It feels like it's been more. Much requested.
Apparently, yeah. Much requested.
Very excited to be here, it sounds.
I mean, it sounds about on his par.
Yeah.
Yeah.
Who's requesting?
We are.
Mostly us.
Oh.
Mostly us, if we're being honest.
We're trying to make this work. So thank you for joining. Well, we have a kind of a complex topic that we've been wanting to talk about for a long time, and that would be EV vehicles. And we plan to have a multitude of podcasts that kind of cover it overall. But Mr. Nalepka here has brought up a very valid point of, you know, students just want to jump into the EV vehicles. But before that, they kind of have to have some fundamentals. Would that make sense?
It definitely does. I guess if we were to look at a lot of the testing that we're doing on an EV vehicle, without understanding the basic knowledge of magnetism, electricity, how to use a meter, you're really lost when trying to diagnose a EV vehicle, where some of the things that we're doing with some of the things that aren't as exciting and have been around for a long time, you can apply those principles to much more complicated vehicles. And if you don't have the foundation, then you can't move forward on anything that's a little more modern.
Yeah.
It's something that's sort of consistent and happens with everybody. You get maybe excited by something as a larger topic, but then you realize you really need to have a good understanding of your fundamentals and the basics.
And if you're a history buff of the podcast, I wanted to fly a fighter jet, but I don't have any talent with that. So I think I'd be more in a Mazda
get you on
Miata first.
Oh, I was going to say a biplane or something.
Biplane.
Yeah. So I guess rolling back to our topic, if we were to look at the demand for the courses, the demand for what to actually learn about, the students, even the students that are coming into the course, the number one thing that I hear is, I want to learn everything there is about electric cars. And I almost view it as somebody like hypothetically is climbing a mountain. They want to make it to the top, but they don't see the mountain. They're basically just want to end up being plopped at the very, very top. And so
you can do that with a helicopter or my fighter jet.
Yeah, but it's without learning our basic skills. You have to collectively put everything together in order to everything you learn in electrical 1, 2, and 3. And this is why a lot of the shops, dealers, they won't even consider you unless you're at the top of your game for learning everything there is to learn about a gasoline powered car before you move into anything that's higher voltage, due to the safety aspects. And one of the things not really talked about, the expense of the components.
For sure.
Absolutely. We look at a EV battery or even a hybrid battery, and the cost can be anywhere from $8,000 up to $20,000. So that's a lot of money. And before you replace a component, that's $20,000. You want to make sure it's actually defective, right? Yeah. So we talk about this all the time with my level 3 students, and I think I said it today in lab, where, you get an ABS problem. I say, what's the first thing you guys do? Some guys say scan it or this and that. And then they say, order the sensor. It's $16. You're like, okay, it might be a $16 sensor, but we still want to make sure that it's defective before we replace anything, because if it's not that sensor, and that sensor comes as a modular unit as part of the hub bearing, now it's a $300 sensor, right? Now up that to an EV where the parts can be thousands of dollars. You want to be very sure before you condemn anything.
What would be the main tool to test some of these components, do you think? I can think of two off the top of my head, but Golly, what do you think?
Well, I think the basic, your DVOM is probably the one go-to thing I highly recommend you get very comfortable with.
Yeah, and the other thing I was thinking was a scan tool. Because,
Totally agree. That's the same thing I was thinking of.
The modern car has so much feedback, but able to take the scan tool's readings, then you need that basic level 1 tool, right? Which would be the DVOM or the multimeter.
Yeah,
and,
you got to interpret the data and understand what you're looking at.
And both of you guys teach level 1 electrical.
Correct.
So you guys teach the meter.
And one of the biggest things that I can say, like just trying to understand and interpret the readings and get comfortable. It's one thing to be able to take a measurement correctly once. It's another thing to be so comfortable with the instrument. You know the settings are correct. And these are some of the things that, as professors that we see. A lot of the people around this table right now, we run our skills competitions, and I can't tell you how often we have students, we're watching them, they have a meter, but it's on the incorrect setting. And they're going through all this testing where a lot of, in the industry, you're using your diagnostic information that's much like a trouble tree. And if you have the wrong readings, sometimes you will still get readings.
Absolutely.
And when we're talking about very high priced components, this can lead you down a path where, depending on who's paying for it, and sometimes it's not the manufacturer, sometimes it's on the customer. Where again, we already talked about the expense of some of them. There's a lot more at stake than what's traditional.
And I mean, even in I'm just actually remembering a conversation you and I had, Garrett. This was a while back. You may recall. We were looking at a wheel speed sensor for one of the Dodge Vipers. Do you remember the cost on one of those sensors? This was, I think, a slightly older model year.
The older model, there's our generation 2, which is there's 2 years where it's 2000, 2001. Where you can't get it anymore, but it was $330 for a single
just
ABS.
for one sensor. Yeah. So
Ouch.
Exactly, right? So, and that's not even thinking about an EV vehicle where you have these components that cost so much more. Just something as simple as what, could be a speed sensor, could be hundreds of dollars. And the DVOM, there are other tools you can use, and some people will say the DVOM is not the perfect tool for everything, which I agree, but it's a very versatile tool that you want to be comfortable with.
Stepping stone.
I think that's the best way to say it. You need to be able to manipulate a meter before you can take on some of those bigger tools.
If I look in my toolbox, that is the single tool that makes me the most amount of money. That's
absolutely.
That's 100% true in my case.
Not your hammer?
No. That's when I can't figure it out.
Some of the things that are changing, though, that I think we're going to start running into and seeing more is we're used to the majority of cars, there's single point failures for, whatever system it is. So if it's a ABS code, it's a single wiring repair or a single sensor or a single module that a lot of times is at fault for the majority. And even if it was multi, you could be into a sensor and a module. Sure, that could happen, but the expense is limited. And the problem is when we start looking at electric cars, pure electric cars, you have 3 major components in that EV, and a very high priced battery, a very high priced electric control unit that is sending voltage to the motor and the motor itself, wherever it is. It can be in the transmission, on the engine. It doesn't matter. All 3 of those components are expensive. And the one thing that's changed is, let's hypothetically say that the control unit, and different manufacturers have different names for it, but generally you have some very large capacitors and you have very large versions of transistors in there. And if they were to short, you could potentially fry a motor and potentially short a battery.
Mm-hmm.
And you could get to a point where you could end up with all three items that are damaged. And as a technician, the ones who are comfortable in using the meter would be able to determine right away when they're first looking at the car, there's more than one failure. And I see this as more of an issue going forward, because a lot of times, let's face it, if a technician diagnoses something incorrectly and it's something that's additionally $200, a lot of times it's absorbed on the work order and everybody keeps on moving along like nothing happened. But we're getting to the point now where the expense of certain items cannot be absorbed.
Absolutely.
And that's one of those things too, where, you know, the worst thing you want to do as a technician at a shop is give the customer one bill, and then after the repair is done, give them another bill saying, also, exactly. Oh, also you need this. And like you said, if it's $200, some shops are going to push it onto the customer, but probably more often than not, you're going to eat that cost and move on. You had thousands of dollars. That's not something a shop can continually just eat. Okay, so if you're that tech who isn't diagnosing things correctly, not giving estimates that are accurate to a customer or complete, how long do you think you're going to be kept around?
Yeah, absolutely.
Right? So we've talked a little bit about this DVOM. First of all, what does that stand for? Can anyone tell me, Mr. Gullison?
Digital Volt Ohm Meter.
Okay, so DVOM, Digital Volt Ohm Meter. What does that mean?
It's a mouthful, isn't it? Well, we can measure voltage with it, we can measure amperage with it, and we can measure resistance with it. So, you know, hence the name multimeter. We have multiple functions that we can do with it. And those three measurements are the ones that we use and measure on vehicles, from gas vehicles to hybrid vehicles to fully electric vehicles. Those are the measurements that we are going to need to refer to and interpret.
And it's not just vehicles. I think I've said this before on this podcast, but I have a DVOM, and when something isn't working at home, it could be as simple as a fuse or
a barbecue.
A barbecue. I know a guy who spent a lot of time rebuilding a barbecue, like a lot of time. So we can, we can use that versatile tool at home to figure out what's going on with your appliances at home. And it's just one of those things you really want to be comfortable with. So one of the first things, or I guess we got to ask ourselves, is I have this DVOM in hand. Now what do I do? What's one of the first things I would do with this meter?
I have my students turn it on.
Great.
Pretty advanced stuff.
That's very specific, Mr. Gullison.
It's a good idea to turn on the tool.
Well, usually like I have them look over it, do a visual inspection, make sure everything is okay. Turn it on, make sure the battery's good too. Is one of the things I like to do. Nothing is more. Nothing. It's hard to start a class and then simple enough the battery dies. So it's a good practice.
Most of these DVOMs, the modern ones, are pretty nice. They'll show you right off the cuff low battery.
Yeah.
Okay, but I've also had some DVOMs that aren't reading quite right, or they seem a little off, and it ends up being a battery issue. But what test could I do to indicate that my readings are off right off the get-go?
So in my class, and it's our room 115, it's a high use room. So we're more likely to see a bad meter in that classroom than you would in industry. And so my students do put the meters on resistance. Mm-hmm. They touch the leads together. They make sure the leads are good. And the other thing I've taught them to do is there's a way to check the fuse for amperage. So basically by putting the meter in resistance, you take the red lead, and you take the red lead. You don't even use the black lead. you go straight to the amp fuse and you see if you actually get a reading or not. And just like I tell my students, if the fuse is blown, the fuse is blown, but at least you know you didn't damage the meter. You can still use it for amperage. You can still use it for resistance, but keep that in mind when you're in the trade.
Amperage if the fuse is blown?
Yeah, you won't be able to get an amperage reading.
There we go. Yeah.
voltage,
So that fuse is used when you are measuring amperage specifically.
Yeah, and some of the multimeters, those fuses aren't cheap either, the internal ones. So
So this is one of those things you want to check when someone borrows your meter.
yeah.
Okay, when they bring it back to you, you check to see if they blew that fuse, and it's pretty simple. As Garrett says here, you just need one lead, the red lead, and you're putting it in the port for amperage, and you're measuring resistance. And if it shows, what would I see if it was bad? What would the reading be?
It'll just be OL, depending on the meter.
Yeah.
It'll be OL. Some of them show a digit 1 on the far side of the screen, so it would be the opposite side of the screen.
Sometimes I've seen just a decimal if it's open, but
And one thing I want to explain is, what does that OL mean? What is that what do those that represent?
So it represents out of limit, so infinite resistance or no contact.
Yeah, and one of the important things when taking a resistance reading is when you show OL or even a reading with your, on the voltage scale, if you see OL, your next step is to change the range of your meter. And if at no range with resistance, you're always OL, it indicates that, that fuse is definitely blown or you're, you don't have a voltage there or whatever it may be. So just be careful with the OL and make sure that if you have a manual ranging meter, you're in the correct range.
yeah.
Okay. You just said manual ranging meter. Mr.
best kind.
Gullison, what's the difference between manual and the other one? I'm going to say auto ranging. So,
Well, the manual one, you can set the range the maximum scale you want to read to. So, for example, some of the ones we have in motor power, we can start reading up to 200 ohms, and we can change the scale to 2K ohms, and then 20K. And, by changing the scale, we're changing the value we can read up to. So, that's one of the things that I find my students struggle with is if you not getting a reading on one scale, maybe change the scale, seeing if you get anything. But you also have to be careful with that because if you're, let's say, sorry, my hands. Sorry, I gotta sit on my hands.
I don't know what to do.
Yeah,
Where do
my
I put my
hands.
my
hands?
hands are right in front of the microphone.
But yeah, you have to be careful with what you're reading because a diagnostic could say, oh, you're supposed to have this amount on this circuit, but it could be on the wrong scale, giving you a misleading reading per se.
Okay.
And I guess with the automatic ones, a lot of people don't recommend them because, they like to have control over their scale that they're finding compared to having the meter look for the reading.
I'm one of
on
those
the
people.
scale.
Definitely, I want manual ranging. No, I will set the
I'm
range.
lazy. I'll take auto ranging.
Yeah.
I simply don't even trust the meter enough. That's what it is. I will set the scale and we'll go from there and see where we have
Okay,
to
if
go.
you can't do conversions, that's your own fault. But come on.
Yeah.
What do you think, Mr. Nalepka?
I'm fine with whatever meter as long as I'm familiar with it and I've used it before. Then I have a lot of confidence in. I learned on an auto range, so I'm comfortable with that. But when I'm talking to my students and around the school, we're using nothing but manual range for a lot of our classrooms, and I see the cost point for actually purchasing a manual range meter. It seems to be better savings for a lot of the meters that are out there. And so with my students, I do recommend, as long as you know and you're being sure of what you're reading and you're confident of using the meter itself, that you could purchase a manual range meter and save some money.
Okay. And, one thing I guess we should also say is when you started that first step, I don't know if we we really dug down into that. But
Yeah,
when
you guys went way too deep, way too fast.
we went on a little bit of a tangent there. But your first step there, when you self-test the meter, you mentioned you checked the fuses and that we would also check the leads there. But I don't think we said, at what point would I say that the leads are compromised? So you're putting your DVOM into your resistance scale or your ohm scale. You touch the two leads together, and what values do you see that you would say this is good or this is bad?
I mean, it depends. Only because we have a high volume of students using it. So
what about in industry, in the shop?
Point 0.3.
Yeah.
0.3 of an ohm. Anything greater than that, you're starting to have leads that you don't trust.
The leads are starting to fail, but I still don't trust the meter until I actually measure voltage with it as well.
Okay.
And I definitely wouldn't, I want to go to a known good 12 volt battery.
Perfect.
And actually make sure that, it's a legitimate reading.
And that's an important thing. I like what you said there. Go to a known good first. Because if you start with a meter at somewhere where you have an issue, you don't know if it's your meter at fault or the circuit itself. So I really like that. Start at your known good.
Yeah, that's a good point too, because with the Ohm's Law trainers we have from ConsulLab, you can see the voltage. And one of the other steps I have students do is use your meter and see the values. Are you close to that the board is displaying? This is a good thing to check as well, to verify that you have. Just because of the volume of students, like I mentioned earlier, who use it. So, you don't know what's happened to it from one class to the next. So it takes 30 seconds to do a quick check instead of spending 2 hours on the lab and you got the wrong answers.
Mm-hmm.
So when I think of a meter right off the bat, or teaching a meter, we have 4 ports at the bottom of a traditional meter that we haven't talked about yet that I think are pretty important. Mr. Nalepka, you want to describe those a little bit?
So we have a common port that you have your black lead in, and essentially that common lead will stay there for virtually all your testing, no matter what you're doing. And then the majority of the time, the majority of the technicians traditionally leave the red lead in the voltage port, because that's the safest area to actually leave that lead. And you're doing all your voltage testing, all your resistance testing in that area. The other 2 areas are strictly for testing amperage. And basically you have to have the circuit set up in a very particular way in series so all the power goes through the meter. And what I've seen in the past is you would actually have a student set that up to measure amperage, take their reading, leave the red lead in the amperage board, put the meter away, and the next time they go to use it, they'll put the dial in the voltage area and go to measure voltage. And unfortunately, with the lead in that area, you will very quickly burn the fuse of the meter.
Mm-hmm.
And you can't put the smoke back in.
No. And, that's another good point. Usually, not usually, but I tell my students at the end of the class, don't leave the meter in any amperage setting. Take the leads completely out if you're unsure, but just don't leave it there for the next student, because if they don't know, then,
So when we look at the ports, you may have a port that's at a 10 amp or higher amperage reading. Okay. And then you mentioned the COM port that we typically use for ground. And then you have a port for voltage, measuring voltage or resistance. And then there's a 4th port, which is also going to measure amperage, but on a lower scale. Okay. So if our high scale for amperage is 10 amp, and you connect that to a live circuit that has more than 10 amps, you blow the fuse. Right? So when would we be getting into something like that? Why would I connect my meter in series like you described on a vehicle? What test am I doing?
So I'm going to put this out, but there's a little bit of controversy with this. So right off the bat, I'll say that there are a lot of manufacturers that would want you to test parasitics on a car with a meter, putting it in series. There are some individuals who strongly believe in using very sensitive amp clamps.
Me.
And there's reasons for both. And I could tell you, like, the only way to get a reading that's 100% certain is to use a traditional meter and put it in series. And I'll give you an example. I had a 2023 Grand Cherokee. It was in a shop for 6 months. It was at another dealer. They had some of the higher ups from Chrysler pulled it out of that Chrysler dealership. They asked me if I could take a look at it. And every 6 days or so, it had a very strong parasitic draw. It would kill the battery overnight, and it was intermittent. And one of the first things I did was I tried to use we have some very nice amp clamps here at Centennial College. And so I borrowed one of those, and I thought, okay, this is great. I'm going to give this a try. This is not something I normally do. But on modern cars, most of the batteries are inside the car now. So I moved the passenger seat all the way forward, gained access to the battery, clamped the amp clamp on the battery. And even as soon as I turned the amp clamp on in the car, the reading was so sporadic because there was an inverter in the center armrest. And that had such strong magnetics that the amp clamp was virtually useless.
Well, I mean, you got to use the amp clamp in a good way.
Some meters have a function called min-max, and there's a special button. You push the button, and basically that meter, its auto-off functions will cease to work. The meter will stay on, and whatever you're measuring will stay on indefinitely. So if I have the meter set up to measure amperage, and I turn the meter on, put it on min-max, I could essentially record the vehicle overnight of its parasitics. And in the morning, when I go to the meter, when I push the button once, it'll show me the maximum amperage that the car was using, the average, and the minimum. And so I had to use that function in order to find what was going on with this particular vehicle. And just because we're all automotive, that particular vehicle was very sensitive. It had a special function that was
Smart key or something?
Smart approach. So this isn't where you have the key in your pocket and you touch the door handle and it unlocks. This is physically walking up to the car when you're in a range of about 15 feet away from it, that it would toggle the air suspension. It would get everything ready for you.
Yeah, proximity key.
Yeah, proximity key. And that setting was overly sensitive for that vehicle and
I think
many
it was
others.
like 30 feet. Like it was a lot, and that was part of the issue. The range was like too good.
It had a very far range. So I even had to the point where the key was locked in my toolbox, and basically, if you were within 30 feet, it was still toggling everything, but it was very intermittent. It was every 5 days or so. So it didn't happen all the time.
Was that a setting that you could change, or was that the module itself?
It's definitely a setting, but it's not something we were thinking about at that time.
Gotcha.
Because a lot of times you're like, what's wrong with the car?
And that kind of goes hand in hand with what I mentioned earlier, with the scan tool being a secondary, like, important tool. But knowing how to use that meter, you were able to verify that.
Yeah, without the meter, I don't think we would have discovered what's wrong with the car.
It becomes a wild goose chase.
Yeah.
Yeah. or just a guessing game, I suppose, without that meter.
When I worked at Volkswagen, we use a scope for that. There was a long-term scope that we could put on, and it would also read something similar. It was built into their scan tool that had an option for that. So you could use a scope as well, but that's going to the advanced level, I would say.
Oh, you work for Volkswagen?
For a few years.
Okay.
He's judging you. He's looking at you different now.
I'm experienced in a lot of brands.
Nice. That's good.
Sure.
So that's talking about, you measuring parasitic draw. And I guess we should probably define what a parasitic draw is. But it's kind of in the name there, and that story gives you a good idea of what's going on. It's some sort of draw, could be caused by what's almost like a normal function of that vehicle, it seems like, or it could be something that's staying on. Traditionally, it used to be like your trunk light is always on, and something simple like that. But with the introduction of so many more electronic components into a vehicle, it could be a number of things. I almost look at, as also a Chrysler guy, it was almost always the radios on our vehicles. Like always the radios. Like you got to draw, okay, order a radio, but you do want to isolate down to what is the issue.
And for Volkswagen guys, it was the rad fan.
Yeah. So, the parasitic draw is basically something that is staying on or drawing more power than it should, killing the battery. So that's where we would use that amperage function.
Until somebody walks over and opens the door on your meter.
Which has happened.
Yeah.
Now, why does that blow the fuse?
Well, that's more than that your tool can handle. Everything in that car is going to go through that meter.
Yeah, and everything's woken up at that.
Exactly.
That's right. So when we open the door, you're awaking the bus, and now everything's communicating and drawing current more than that 10 amp or whatever it is. So what could I do? Is there anything we can do to protect our meter?
Yeah, use a amp clamp.
Well, tape the door shut.
The caveat to the amp clamp is because it's a fairly quick check for me, and then if it didn't solve anything, I would then move to my meter. So it's a starter point for me because I don't trust my coworkers.
Right.
Especially on that lunch break when you leave your tool unattended.
Well, I was just talking to Justin here. He was doing some special things to his leads in order to try and protect the internal fuse. So maybe you could speak to that.
Yeah. Being going through the learning process, things happen, and typically, when you hook up the ammeter incorrectly, we kind of mentioned that you could pop the fuse inside. So it can be troublesome to take it all apart. So what I've done is I've actually put an inline fuse in the lead, the red lead that is. So that way, if you make an error, you pop the fuse in the lead, which is a little bit quicker and doesn't damage the meter. So it's kind of a safe mode or fail safe.
Yeah.
So
and some of the meters, the expensive fuses, they call them a slow blow fuse, so they can take a quick spike in amperage. A lot of the common automotive fuses they're not set up the same way, so they will quickly blow before the expensive fuse does. And if you don't know or aren't aware, if you work at a dealer or shop, a lot of times if they're changing a fuse box, the fuse boxes come loaded with fuses. So a lot of times there are ample amounts of free fuses at any particular shop.
So Garrett, I guess you haven't gotten this memo. Dodge does say that they want all their fuses back in the new fuse boxes. That was an actual case or thing. They're like,
was a memo.
They're like, we want our fuses
You've been at
back.
the college too long.
So it may depend on your manufacturer there.
I still haven't got their fuses back. I still have never given them a fuse box back. Never mind.
So when you added that fuse, though, when you check your leads, is there any different thing you have to do?
I mean, there's nothing different that you have to do per se. You can still, put your meter setting on resistance, touch your two leads together and see your reading. It may be a slightly more because we've added additional components in.
Yeah, that's what I was kind of getting at.
Yeah, but not enough that I would feel it would cause any major difference in readings.
Okay.
Maybe if you're getting into some sensitive electronics, maybe some people will argue that could cause that, but for what we're doing on the boards,
you're doing on the light board,
it's fine.
Yeah,
yeah, and it's a good learning experience too, because when the fuse blows in the lead, nothing's working because it's an open circuit in the lead. So, the students can call me over, we can get the fuse, and we can talk about what did you do, what happened,
right. What'd you screw up?
Well, yeah, what can we change going forward? So, they don't,
it's a good learning exercise.
Yeah,
even in that mistake.
Yeah, I find after that happens, typically it doesn't happen again. But I can't say that.
You got to learn from failure.
Yeah. And I'd rather it happen here than out in the field. We can get fuses relatively quickly here, so it's better to make an error here and learn from it than constantly making it out in the field. So.
Yeah. So that's the amperage. I think we covered it fairly well.
Mm-hmm.
You kind of talked about resistance earlier, and you said that when you're checking that fuse, that amperage fuse, as well as testing the leads. But what is resistance?
It's opposition to electric flow. So we use it to measure a wire to see if it's has continuity. A lot of the tests in automotive, they'll have you do resistance tests. So say if I was to simplify, say you had a sensor or something that was bad, they typically have you disconnect the computer, disconnect the sensor, and you're doing a resistance test from the component to the computer. And you're also probably doing an additional test to ground to see if it's shorted to ground.
You said something very important when doing a resistance check or an ohm check, and that was to disconnect the component. You have to disconnect it at that point.
And I think that's
proper value.
A big thing the students forget to do is they're getting an odd number, and
one of my gripes with Electude quickly is that you don't have to disconnect the components to get a good value if you're using the simulator. So I would challenge all of our students, even if it may give you the right value, do it properly, because in the lab or in the shop, you have to do that.
Best practice.
So why do I have to kill power to this circuit to test the resistance?
So the way a meter measures resistance, it's sending power from one lead to the other. So if you already have power flowing in the circuit, you're still going to get a reading. And the problem with that is the way our trouble trees and our diagnostics work in automotive. A lot of times it'll say something like, if you have a value above or below this, change this component. And if it's incorrect reading or erroneous reading, quite often you're changing the wrong component.
Okay.
All because of the technician's error, which is an issue.
Failure to put the circuit in the correct
test condition. And that's one of the things I think is a big challenge to the meters, not just setting it up correctly in the circuit, but also having the circuit in the correct state.
Yeah.
I like that a lot.
Okay.
Yeah.
And I can tell you, my meter, a lot of these meters have a little power button. And I mentioned before, the battery, or sometimes it doesn't tell you low battery. I would throw my meter in my electrical drawer that was kind of filled to the brim just as I added more and more stuff. And the meter would sit on top. And I would find is every time I go to get my meter, the battery's dead or the battery is low. And it was just from stuff touching the power button.
Yeah.
Right?
That's why I buy a Fluke.
Sometimes it didn't give me that low battery message, but I would realize that my resistance readings were not right. And sure enough, it was because that battery is dead or was low on charge So because it's using that battery by sending power through the leads there to measure resistance, it will affect your readings. And I would change the battery, put a new one in, and all of a sudden it's reading correct now. So that self-test we talked about is very important because you can catch that. If you don't do that quick self-test of the leads and your resistance values aren't good, you start taking readings that are wrong.
You start wrong, you end wrong.
Exactly. And just like Garrett said, a lot of our trouble trees, they just say, is this your value?
Yes, no.
Replace this.
Yeah.
Right? So,
Yeah. And you're not the first person to say that. I actually had Jason D'Amico came to me today and warned me with the meters that we're using. Don't expect to have a accurate resistance reading if the battery is low in the meter. So you're not the first person to say
the
that.
same meters we use here is the same meter I have in my toolbox. I've had it for like 12 years, maybe more. I love it. It's a great meter. And I've just moved it into another drawer so my battery stops dying.
And we would totally promote Snap-on if they want to sponsor the podcast. But Flukes have a little switch that doesn't have a button.
But the Snap-on one's red.
These
so's my box.
These take your 9-volt battery. So we just bought a bunch of rechargeable ones. So you don't have to keep buying them. Just go and recharge them. So
That's
you have
for
a good
the lab, though. In the shop, I just have a few 9 volts in my box and just kind of work through it.
Yeah.
Well, it was
Have
at
a
one point
backup
going
on
through
hand.
a lot because it kept turning on, but now it's all good.
Yeah,
All
that's
right. So the last function, I guess we could say, would be voltage.
Probably the one that's used the most.
I would think so.
Yeah. So
I think it's the one that most people grasp quickly.
okay. So
Maybe. I don't know.
what is voltage?
Well, I'd say it's the pressure within the circuit is how I usually describe it to my students, and it's one of the first things we go through and have them check too is voltage, like just on a simple battery, even your little
9 volts.
9 volts or your AA battery, get 1.5, and we start check that, see. Measure the voltage on that.
One of the nice things about measuring voltage is the students can't really destroy any equipment and they can't hurt
Through
themselves.
the wire.
So, and if we start talking about pressure and we say, okay, in a circuit, just like if we were to talk about hydraulics, you could have 20 pounds of water pressure in a pipe. And that pressure, if we were talking about electricity and just trying to relate it, we would be talking about the pressure, not necessarily the amount of water, but the amount of pressure in that electrical circuit. You start talking about flow and the amount of physical liquid, that would be equivalent in electrical circuit to the amount of amperage or electrical flow. So voltage, you can measure it any which way and you won't damage the equipment. So
it's the starting point at school.
Yeah, I like to think so.
Yeah.
Yeah.
And how would you check for voltage on something? Well, we've talked about the COM port and the voltage port, and then where are those leads going?
Yeah,
Like, what are you
usually
kind of working with here?
Yeah, like so the black lead for this test remains in the COM port, and then the red lead stays in the voltage port. And as long as you set your dial to read the voltage scale, as long as you turn the dial to the voltage scale, you'll pick up.
And I would
pick up
say
a
that
reading.
when we're measuring voltage, the way I look at it is there's 2 different types of measurements you're primarily going to take: available voltage or voltage drop. And I think that's where we start to get a little bit of confusion.
Yeah, most definitely.
So if we say available voltage, I don't know if that's a term I use. I'm not sure if that's a term you guys are using or in the same way.
I like it.
Yeah.
Because let's say open circuit voltage testing, but it's the same thing. It's you can test a circuit 2 different ways. You can, if I have a simple circuit set up with a battery, 2 bulbs, a switch, and so on and so forth, I can do my testing by taking the black lead, leaving it on the negative of the battery, and going around looking at the amount of voltage I have in the circuit. And you should see a certain amount of consumption in certain areas. If you see it drop off in the wrong area, you know that gives you an idea where your problem is. And the other thing that you could do that I find is a little more advanced is voltage drop testing, where you're putting the leads on either side of the component. And so one of the things that we've pushed in our 8226 co-op programs is trying to do voltage drop testing right off the bat in our level 1. And so a lot of our labs and materials, they're voltage drop focused. Both Professor Mary Green and myself, we decided we were going to push that a lot more, being that we were having issues with it when we were getting into the higher levels and talking about testing. Where
I feel like a lot of industry's gone that way too.
Yeah.
With the testing.
And I've
Absolutely.
actually seen that with Chrysler service information, where in past where they would have you measure the resistance of a circuit, now they're starting to say voltage drop that circuit.
Yeah.
And not just the component, but also the conductor as well, right? We can voltage drop pretty much anything in that circuit, see how much voltage is eaten at that spot, and go from there.
So I guess we need to define voltage drop.
Yeah,
And I kind of like the word you use, eaten, because I use
Yeah.
it the same way.
That's
I say
how
consumed.
I say
It's easy to
voltage
understand.
consumed. And again, it's
So how do we?
a food thing.
So how do we explain that?
It's a food thing.
It's always a food thing with this guy.
The pressure is not making it where it needs to be, is basically what's happened. So you can start off with a certain amount of pressure, and there's something that is stopping that pressure from getting where it needs to be in the circuit.
Such as like a resistance.
Yeah, excessive
Oh,
resistance.
kind of like my shower.
Yeah,
Yeah.
lack of, more of. Yeah,
So one of the big things, if we're looking at a meter, taking a step back, we talked about resistance, and we talked about traditionally doing a test, saying we want to measure a wire, make sure it's in good shape. We unplug the computer, we unplug the component, we measure the resistance between the two. And for years, all service manuals, diagnostics, they had those tests. The problem with that is, let's say the wire isn't completely broken. If you take a wire and you were to look at the wire and start peeling back the insulation, you have several strands of wire. If I take every strand and cut them all but one, my resistance test will have a good reading. It'll tell me that wire is in good shape. The continuity is fine. Move on to something else. And unfortunately, that one strand of wire may not be sufficient to operate the component. And this is when we get into the next level, and using the meter to its limits is using voltage drops, where you actually have the component in operation, you're using it, and you're measuring voltage, as in pressure, through the wire, and you're seeing if there's any loss in pressure in that wire. And so I would still say that most technicians won't diagnose that way. I think of it as being more advanced, and you need to understand electricity to be able to set it up and test that way.
Yeah, I have a story here that's kind of related to it about voltage drops. And I don't know if actually Garrett remembers this, but I don't know if anyone else knows that's listening. So I used to work with Garrett at the dealer. And when I was an apprentice there, I can't remember the story 100%, but a car had come back a number of times because either the battery kept dying, something to do with the technician believed it was the alternator wasn't charging the battery and maintaining that voltage, something to that effect. And these components kept getting replaced. And I think you had the opportunity to look at it with a fresh set of eyes. And I was there as an apprentice. So I came along, and I think you did a voltage drop on the positive side of the circuit for the battery and found an excessive reading. And when we had taken the cable off the battery and off the other side of the alternator starter, I can't remember where it was going, it was corroded. There was a pin-sized hole, and half those strands had corroded away, and there was only maybe 10 strands still attached. So that was causing excessive resistance in that circuit. And, that's a story I kind of tell in the class why that voltage drop testing with your meter is so important.
So you had put 2 to 3 alternators
Not
in
me.
the car. And then Garrett took over.
No. I think if at the time I wasn't doing it, being a level 1 apprentice, I don't think I was doing that, but I was definitely watching that.
I've had
happen.
something very similar where I had this was when I was an apprentice. I had a Durango or Grand Cherokee. I don't quite remember, but the driver's side window switch didn't work. This car had like 700 kilometers. So the driver's side window switch is not working at all. I do exactly like Garrett said. I measured the resistance as per the service information. It's like, good. You go through it. It says replace the window switch. Now, the benefit of being at the dealer, I just walked onto the lot, grabbed the window switch, popped it in, and it didn't work. And I was like, what's going on here? Right? Something's not quite right. And as I further looked into it, and as an apprentice at that time, I didn't understand voltage drops very well. But this is where I first learned that lesson that a resistance check isn't going to cut it. Because the exact same thing happened as Garrett described. I had the wire was caught by the parking brake pedal bracket from factory. They caught the harness when they installed it at factory, and there was like maybe 3 strands of wire, not enough to carry the current to get the window switch to function. Mm-hmm. And that was like an aha moment for me. That was I cut that section out. It's probably still somewhere in my toolbox today because that was lesson learned, right? But it really drives that point. It did for me that a resistance check is only good enough to tell me, is that wire broken? But it doesn't tell me the condition of the wires themselves.
Yeah, and I think we can tie that back into what we were talking about at the beginning with EV vehicles, right? Just the basics on a 12-volt system versus a EV vehicle kind of travels through the whole way. Wouldn't you agree, Garrett?
Definitely. The biggest thing I look at is if we were to go to any shop and we were to see how a technician was using their meter, I would say most are not using it to the limit where they could.
The potential, yeah.
The potential of that tool. Mm-hmm. And I'd say a lot of technicians, they're still doing testing. They're still using it, but they're not certain that what they're doing is going to actually fix the car until the components change.
So a challenge for all you students and technicians that are listening are take your meter out and try some things. Mm-hmm. Go a little bit further. Take yourself one step past and be better.
Mm-hmm. And even if you're doing a resistance test, double check with the voltage
drop. That's awesome. I think it's great for anybody. I remember being in the shop, the same thing. Kind of nervous of that test. So just try it. Mm-hmm. Not an amperage though.
Yeah. And you'll get more comfortable with your own
on
meter.
someone else's meter.
Or someone else's meter. Yeah, exactly.
All right. So we have one question today to close out the DVOM. Mm-hmm. And it's kind of a callback from an interruption we had in the podcast. But if you were to order 2 pounds of wings right now, what's the flavor?
Oh, that's a great question. Do you want me to?
Justin's just dreaming right now.
I know. I'm thinking I got like 30 flavors in my head right now. I don't know. The hot honey is always my go-to.
Hot honey.
I would just do medium just because.
Just straight medium?
Yeah. You know what? Because you can get the hot sauce and make it hotter if you need.
Okay. All right.
Mm-hmm.
I'm a huge Garpar fan right now.
Yeah,
garlic
good.
Parmesan or lemon pepper.
Lemon pepper's good too.
Can't go wrong with the lemon pepper.
All right, Justin.
What's
the you're
daydreaming
now?
We could have a whole podcast on just chicken wing flavors, anyways. But
I think that's already a podcast.
yeah, that's true.
It might be this little podcast
called Hot Ones.
Yeah. How do I get on that one?
All right, guys. Thank you so much for joining us again. It's such a pleasure to chat with you guys and learn something about DVOMs and how we can implement them in the shops and in the labs.
And if we missed anything for the listeners, let us know. Send us an email or yell it at us down the hall, which is the way it tends to go.
Yeah. And I'll say that's all, folks.
This has been the Talking with SOT podcast with Harnett Gill and Ian Campbell. Thanks for listening.